Thank you for tuning back into the Automation Podcast. My name is Sean Tierney from Insights in Automation. And this week on the show, we have a special guest, somebody who hasn't been on in 4 years. We have Michael Bone from PI. They're the folks who manage technologies like Profinet and IO-Link. And Michael's come on this week to talk specifically about IO-Link. We're going to talk about what it is. We're going to talk about when you should use it. And we're going to talk about the technical details of IO-Link, like all the things like engineering minds like to know about. So I think you guys are going to enjoy this. It took about 2 to 3 hours to edit this one, and I really enjoyed going back through it. We recorded it, I think, 4 weeks ago, so I hadn't seen it in 4 weeks, but I really did enjoy it. I really think you guys will enjoy it too. And that brings up another point. Organizations like PI and ISA and other organizations, they're not vendors. They don't sell stuff, right? And so this episode's not sponsored by a vendor. And, as I was going through it yesterday, I was like, there's a lot of great slides in here. I want to share it with the public. So I've decided to sponsor this episode myself. And I'll use this as an opportunity to tell you a little bit about my company and the automation blog, the automation school, and the content I have planned to release this fall, including content on these products right here, all focused on IO-Link. And I just actually did a live stream with these products in front of me. I'll be doing more tomorrow, and I'll be adding lessons to my courses as well on these products. So in any case, but before we get to that, let's go ahead and jump right into the show and hear from Michael and learn all about IO-Link. I want to welcome back Michael to the show. It has been 4 years. He was last on in podcast 76 back in September of 2021. So just going on 4 years. Michael, thank you for coming back on the show. If you could, a lot of people may not remember 4 years ago. So before we jump into your presentation, which I'm so excited about talking about IO-Link again, but before we jump into that, could you please tell them a little bit about yourself and a little bit about PI?
Yeah, sure. First of all, my pleasure to be back on the podcast. It was a lot of fun. I remember that back in 2021, and I'm glad to be back and doing it again. I started with PI North America in 2011 as the technical marketing director. And since 2016, I've been the executive director running the show and chairman of the board since last year. I have the, let's say, pleasure to serve as the deputy chairman of PI on a global scale since 2015. And I come from prior to working for PI, I worked for a sensor manufacturer who had some interfaces on there that brought me an introduction to Profibus and Profinet. And before that, I studied physics and math at Penn State University. Just really quick for those, I'm sure many of you are familiar with PI, but it was started in the late 80s. Half a dozen companies and universities got together and they wrote the Profibus spec, and that evolved into Profibus DP and Profibus PA for process automation in the early 2000s. Profinet came under the umbrella. And the reason I bring all this up is because there are some newer technologies under our umbrella that I think the audience might want to know about. Of course, IO-Link is the one that we'll talk about today, and that was in 2009. But there are some others like Umlox, which is a location tracking standard. There's one called MTP, Module Type Package, NOAA, NAMR Open Architecture, also under our umbrella. And basically what we do is promote, maintain, write the specs, turn them into standards, and the work on those specs is done in working groups, which are staffed by volunteers, engineers from member companies. They donate their time to develop the specs for these technologies we have under our umbrella. And we're a little bit unique in that we're decentralized. So we have competence centers and test labs and training centers located throughout the world. It's not all just in one headquarter kind of place. And they're all independent, but they have a contract or a quality of services agreement with PI that says, hey, if you have a question about the technologies, go to a competence center. If you want further training, go to a training center. If you want to test a device, go to a test lab. And then they are all working with regional PI associations, of which PI North America is one of them. We were founded in 1994 by a guy by the name of Mike Bryant. At that time, we were called Profibus Trade Organization. And we are and now I didn't come up with this name. We are the North American Rio League. This is an IO-Link designation, a regional IO-Link interest group, which means that we have a separate contract and quality of services agreement with the IO-Link community to promote and work with members specifically for IO-Link here in North America. And we're nonprofit, member supported. I got nothing. So you were talking about products and stuff at the beginning. I got nothing to sell today. We're working solely on technology.
I do want to throw out there, though, you have a great update every month about all the new products that fall in the buckets of IO-Link, Profinet, Profibus, and a lot of those new products, of course, are IO-Link. So while they may not have products of their own, they do keep the industry up to date on who's joining up and signing up for the jump on board and release new products that meet these specifications. And you know what? Maybe you're not using Profinet because you're using brand X or Y. You still probably use an IO link. So
Oh, that's for sure.
very interesting updates that you publish every month and as a blog. And I know when I was doing the news for a couple of years, I would always go to your site to look for new updates.
Cool. Yeah, yeah. I guess I got a slide on that at the end, but you're referring to the Profi News.
Yes, the Profi News. Yeah.
Yeah, yeah. That's been a baby and a labor of love for a while now, and oh man, it's incredible because every month well, we track this kind of stuff. Obviously, the most popular article is the new products one because that's what that's what people want is the stuff they can buy, the stuff they can use. Yeah, yeah. And we got another one coming out next week, and every month we push that out, and it's always half a dozen or a dozen new products, half of which are IO Link. I mean, it's just growing like crazy.
Yeah, and you guys have had some good articles. I think you had a great series, and now I'm stretching it, so stretching the old memory here. I thought you had a great series on MTP, which I really enjoyed. Did I remember that correctly?
Yeah, we try and we try and get some editorial content in there. Falls into like three main buckets. What's new products? What are new trainings and events that are coming up, and then some editorial content. I think what we're driving at is I think we need to do maybe an MTP podcast here at some point down the road.
Probably, yeah, down the road, definitely, definitely. I'm still very, I still have a very casual understanding of it. But let me throw it back to you because I kind of jumped in and interrupted your update.
No, it's good. It saves us at the end when that slide we can just jump over it. Now we've got it covered, and it's an important one. But you kind of gave me a nice lead into the next one, which talks about the IO-Link community, and I'll start from the bottom, work my way up as being field bus independent.
I just want to break in here for a moment and thank you folks in the audience who've signed up for my membership program. Really, really appreciate you all. 18 months ago, after reviewing 10 plus years of being on YouTube, it was pretty obvious that there's no real revenue on YouTube. I mean, it comes in at maybe 1% of my monthly expenses. And so that av revenue there is just not something to rely on going forward because it's not something that's been reliable in the past. And so I started up the membership program, both on YouTube and at theautomationblog.com. And I want to thank all of you who signed up. We have a $5 tier, which I know most people sign up at, and then we have a couple other higher tiers. And so I just want to thank you all for doing that. You are actually, the membership program's probably 3% of my monthly revenue. And so that's, one or two times more than what the YouTube revenue was. So thank you all for that. And I hope that some of you who are not part of the membership program will consider becoming a member, supporting my work so I can do videos that are not always sponsored videos. Now, I love sponsored videos. I love it when a vendor sends me a piece of hardware and then sits down with me and teaches me how to use it so I can create a video ad-free and share it with you on how to use that product. Or maybe they just come on the podcast and sponsor it to make it ad-free so we can tell their story about their product or service. And I will continue to do that going forward. But I would really also like to do more audience-generated type of content. So content where you generate the idea and say, Sean, why don't you try this? Or Sean, why don't you do this? And a lot of those topics that the audience wants to see, they're not necessarily topics that the vendor wants to promote with advertising dollars, okay? And so that's the whole purpose of the membership program. Like I said, right now it's around 3% of my monthly income comes from, and I'm talking about the business income, not my personal income, the business income, 3% of what the business needs to move forward and pay its bills every month. But still, so many of you have decided to jump in and support me. I just wanted to stop and say thank you very much from the bottom of my heart. And if you're not a part of the membership program and you're doing financially well, please consider if you enjoyed. This is episode 246 of the Automation Podcast. Every episode has been free. The audio has been free for all 246 of them. And most of those episodes I funded myself just by well, you can understand how you fund something when you don't have the income coming in. But in any case, if you enjoy it, please consider becoming a member and we can branch out and do other things together. And with that, let's go ahead and jump back into this week's episode and learn more about IO-Link.
So like you said, yeah, I mean, organizationally, the IO-Link community came to PI in 2009, and organizationally under PI, because we have the infrastructure for working groups and IP policies and contracts and things like that. But the IO-Link community has their own steering committee, and from the outset and from every IO-Link event that we do and everything that we do is independent of any Profibus or Profinet stuff, and we try really, really hard to maintain that independence, no matter what vendor you're using. And there, at this point, we've got 500 companies in the IO-Link community, and it's really just growing by leaps and bounds. So we kind of track this stuff by nodes, and all the IO-Link companies, they send their node count to an independent auditor, collects the counts, and gives us back an anonymous total. So we don't know where or who is selling them, but we get the total, and you can just see this hockey stick exponential growth. Particularly in 2023, there was some supply chain overpurchasing that went on. I mean, that's like, we're looking at a growth rate of 89% there, which is obviously unsustainable, but still, last year, 9.7 million nodes were added. Again, because it's Fieldbus independent, it really has no competitor. And that's what's kind of cool about IO-Link. I mean, you want to do, and you don't need to choose a Fieldbus and therefore get IO-Link. You can use any Fieldbus or industrial Ethernet protocol, and IO-Link works with it.
You know, I want to just mention for the audio listeners, if we go back to 2012, it looks like we're probably at the 1 million mark or below it. And as you go to, 2022, you look like you're 35.7 million. Is that 2022 or 2023?
Yeah, that's the end of 2022. Exactly. 35.7 million. Yeah.
And then at the end of 2023, we're at 51.6. So you talked about that, overbuying. And then at the end of 2024, we're at 61.3 million. So you can just see from, 2022 to 2024, you went from 35 to 61. So the adoption, like you said, it's a hockey stick. The adoption has really picked up. And I think you hit the nail on the head because it is Fieldbus independent. It's a way to just get more information out of our devices like sensors and photo eyes, and it's just, I mean, these chipsets that come in these devices now are just amazing.
And that's what the whole point of this is. You're not going to put a $5 Ethernet chip, like $5 Ethernet interface on a $15 proximity sensor. Mm-hmm. But computing and memory has gotten really, really small and really, really cheap that it's on just about everything. And so this proximity sensor not only can tell you if, like, for example, let's say it's on a conveyor belt. It can not only tell you if the box is there or not, but it can tell you how many blue boxes went by or how many red boxes went by, or if the box that's going by is off kilter or misaligned or something like that. But how do you get that data out inexpensively? And here we are. IO-Link is the way to do it.
I'm starting to see a lot of these sensors too come with humidity, temperature, and all these other things. You'd be like, really? I can get that out of my photo eye? But yeah.
Multivariable, exactly.
Yeah, well, yeah.
Traditionally with an analog interface, how did you get that? You couldn't get it. Mm-hmm. But now with a digital interface, which is what we're talking about, digitalization in the last meter, now you can get that information, that data, that information, and do some pretty cool stuff with it.
Yes, you can, yeah.
I'll talk a little bit about the architecture a little bit here to kind of get a little bit into the technical side of things about how IO-Link works, but they're kind of some main devices, and that's the IO-Link masters and the IO-Link devices. And these IO-Link masters are available we have here 16 different industrial Ethernet or Fieldbus systems. 21 manufacturers offer central PLC, like an IO-Link master built into the backplane of the PLC, if you so desired. And the number of devices that hockey stick we showed before is just exploding. I mean, we've got 60-something million sold. And we have tens of thousands of unique IO-Link devices from hundreds of different device manufacturers that have implemented this interface. And for those that, if there's anybody on the podcast that wants to do this and add this to their sensors, there are a number of different companies that help with product design, either with the chips, the transceivers, the software stacks, and then a number of companies that help provide technical support in order to do that. So an IO link system kind of is made up of four parts. Like I said, you have the IO link master. That's the gateway between the IO link devices, the IO link interface, and the higher level communication systems, such as the field bus or the industrial Ethernet protocol or backplane. You have the devices. This is the exciting part. Your sensors, your switch gears, your valves, your signal lamps, maybe some simple actuators, whatever the case may be. You've got a IO link cable, just a 3-wire, unshielded, super simple connection between the master and the devices. And then every device has an IODD, or IO link device description file. And I'll explain how that gets used to engineer and parameterize the IO link system and the devices. And what this kind of enables, traditionally, communication only reached the IO level. You had connection between the PLCs and the IO, and then it kind of stopped there because all those sensors and actuators were not accessible. They were analog, and you got your one process data, you process signal, and that's where it ended. But with IO Link, what we do is we enable that communication bidirectional, cyclic, and acyclic, and that's the cool part, all the way from higher level systems, not only to the PLC, or especially from the PLC, but down all the way down to the simple sensors and actuators, which are now accessible. And you kind of touched on this before, where these chipsets have gotten really, really smart and really, really powerful. And it's not that any of these use cases that are being solved with IO-Link, that none of them are new. What's new is the ease with which they can be solved. So because you can get all this extra data out, things like OEE, showing things like downtime tracking, track and trace, predictive maintenance, for example, remote monitoring, recipe management, SPC, all these things. It's not that these use cases are now being solved. We've been doing this for a long, long time. It's just the ease with which, because it's a standard, and because all this stuff is standardized in how it gets from the device to the master and upwards to the controller, it just makes it easier. If you spend all your effort trying to gather and collect and sanitize the data because every device is different, and that's just a mess, and the ROI disappears really fast on any kind of project to do that. But if we have a standard on how to do that, then we make it very, very easy to do, and everything can come in quite nicely, and it just works a whole lot easier. You start getting access to that data. And so what we're starting to see is connections being made. You talk about the flattening of the traditional automation hierarchy, where now not only is that IO block or that sensor connected to a PLC, but it's got some extra data. Like you said, like this little photo eye might have a temperature or a moisture sensor also in there, just because it's part of the chipset. But the PLC don't care about that. He just wants to know about the information from the photo eye. So what do you do with all this extra beautiful information that isn't necessarily processed data? Well, maybe the MES wants to know about that. So how do you get that? And in a running factory, in a brownfield environment, rule number 1 is don't touch the running PLC.
Yeah.
And rule number 2 is see rule number 1. That thing is running, and any minute of downtime costs more than any one thing on the factory floor.
Before we go on, I did want to break in here and tell you a little bit about my website, theautomationschool.com, where I do my online training. I also do in-person training. And you probably don't know that all started back in 2014 with a Kickstarter I ran for my first PLC Basics course. At the time, it was called Microprogrammable Controller Basics, and I ended up changing it just to PLC Basics. But in any case, since then, I've added a dozen courses on a various number of topics, and you'll find them all at theautomationschool.com. But what I really wanted to talk to you about is why. Why did I do that? Well, I had spent 25 years as a certified authorized Rockwell Automation distributor specialist covering PLCs, HMIs, SCADA, MES, and other stuff too, right? And I knew from visiting customers in the plant every single workday, almost every workday, that there was a real need for affordable training. So the first thing is, large companies have large paychecks and lots of overhead, so they got to charge a lot, right? And so that was a problem because a lot of the people I was working with, the controls engineers, automation engineers, high-end electricians and technicians, they had to fund their training themselves. Their company was sort of like, no, we trained this guy back in the 90s and then he well after and got a better job. So we're not spending money on training. And so all these people were having to train themselves, and it was unaffordable to either, buy the vendors' courses, or even if the company didn't have training dollars, it was unaffordable to send them away for a week to a $3,000 course somewhere halfway across the country, probably $3,000 worth of travel and hotels too, right? And then they go without one of their smartest guys, right? One of their best people, because that's usually who you're going to train and uplift through the organization. Either people who are doing good on the lower level, you want to bring them up and train them on automation. And so that's why I started the automationschool.com, because of the try to provide. I knew the courses would never be Hollywood quality. I mean, this isn't Hollywood quality, right? But I knew it could be helpful and be affordable by just filming them in my garage, right? And picking up some used equipment and putting together the episodes. And the site has grown so much. We have thousands of students from over 150 countries. We have hundreds of vendors we work with. But the other thing I did is made it buy once, own forever, right? So more like an ebook or an audio book or an MP3 album, right? And the reason I did that, and I understand why the vendors don't do that, because they're like, well, they'll sign up one guy in the I&E shop and he'll share his password for everybody. That could happen, right? People could rob a bank too. But I'm like, most people, when they buy a course, and I saw this, I was on an independent platform for a while, and on that platform, they showed you how the progress of every student. Most people buy the course well before they're ready to take it. And I'm like, I'm not going to charge people a monthly fee or only give them access to a short window if, they have good intentions now, but it takes them a while to actually free up their schedule to get into the course and take it. So that's why my courses are buy once, own forever. And it can, as they grow, the price goes up because I'm adding more and more content, and I do split them out and make cheaper versions over time. But those people who buy in early, they get like my S7 course. I think it originally came out at $40 or $50, and now it's $200 because I've added so much to it over the years. But in any case, same with control logics and compact logics. And then the other thing too is I want them to be able to take it more than once, right? So if let's say you take a control logics course, right? You don't use it for a couple of years, you're probably going to have to take it again. And I don't want you to feel like you have to pay a monthly fee to do that. It's like an ebook or an MP3 album. You bought it, you bought access to it, I guess I should say, and now it's yours, right? And the other thing too is I support my students personally. Okay. So I check the website every day for questions, every work day, I should say. I do take Sundays off. So in any case, if it's a work day though, and I'm working, I'm not on vacation or traveling for business, I'm up there, I'm answering questions. And I should say, even when I'm traveling on business, I'm on there answering questions. So although if I don't have any hardware, there's some questions you can't ask, right? I guess I should have said some questions you can't answer. But in any case, I just wanted to share that with you. The automationschool.com, high quality online courses, 5-star rated, buy once, own forever. And guess what? I'm updating all the PLC courses. And if you already own or buy one of the existing PLC courses, you not only get the updated lessons that get added to that course, you get the new course completely free. So I'm not going to charge you for just an updated version of a class on the same on the same products, right? That would be kind of silly in my opinion. So I hope you guys appreciate that. And again, if you didn't know any of this, if you have any questions, if you go over to the automationschool.com, at the very top of the site, you'll see links to contact me, set up a meeting, leave me a voicemail, fill out a form. I have many ways you can get in touch with me. And if you have multiple people you want to sign up, I do have multiple seat discounts starting at 3 seats. And I do actually work with a number of Fortune 500 companies who, enroll maybe 10 people at a time to get that discount. And you know what? Unlike the big vendors, if you sign somebody up and they don't take the courses, I'll let you replace that person for free of charge. You don't have to pay anything extra. If you sign up Joe and he decides to quit or leave or not to learn, you can put Bob in his place. That's not a problem. Now, I have had some situations where the same spot kept getting replaced and replaced and replaced. At some point, I do charge a maintenance fee to switch the names out. And then, hey, look, if Joe leaves and he took, 2 out of 3 courses, I'll prorate refilling that seat with the new person, right? So whatever percentage of the lessons he took versus the total number of lessons, I'll prorate it. So, we've had a number of cases where somebody goes through half of the content, then leaves, so we can reset that seat for half price. And that's something you won't find any major vendors doing as well. So if you have any questions about that, reach out to me over at theautomationschool.com. And with that said, let's jump right back into this week's episode of the Automation Podcast.
In a brownfield, installation, what we're seeing are these cool little edge gateways. And what they'll do is they'll grab the bus, they'll collect some data and pump it out the other side via, maybe an IT protocol that the IT guys want to know about, or, like an MQTT or an OPC UA. Of course, in a greenfield, in a new installation where you've got a brand new PLC, yeah, get the data there. That guy has all the brains, has all the information all in one place. So get it from the PLC. But in brownfield, the edge gateways, even some IO-Link masters are being put on the market that have not only an industrial Ethernet interface, just on one port, on the same port, an industrial Ethernet interface for control, but that interface will also speak like a higher level IT protocol, like an MQTT or an OPC UA, so you can get it even from the IO-Link master. That data is accessible. So there are different ways to get it, and that's kind of the whole point is getting that data from the sensors to the master and then further upwards.
We actually covered a product on the show that had two ports. It had one for your field bus,
Yeah,
and then it had a separate one for your IT or your IoT or your MQTT, which I thought was so inventive too, because now the control system gets its data and it's under control. But reporting wise, that's kind of the best of both worlds. You don't have to have two sensors. You can send the data both ways. And yeah, just it's what you can do with these things. And, you know, a lot of the sensors you probably have out there, I've noticed that some vendors, every sensor they sell is IO Link. So
yeah.
you may already have it installed and not know it because the price difference to add it to some products. Once you get up to the fancier sensors, of course, not the simplest sensors, but once you get up to the fancier sensors, it's there's a lot of horsepower in that chipset. So, they can add IO Link for pennies on the dollar. So very interesting stuff though.
Yeah, that's a good point. And of course, we could spend all day talking about IT, OT, and the segmentation of networks, and who owns the IP addresses, and that's a whole separate topic. But in cases like that, yeah, it's cool. You got a separate port. IT can do what they want on their one port, but hey, don't touch me in the control realm because this is my realm. And you bring up another good point, and that's kind of I don't want to say that there isn't like a thick black line between, okay, this sensor is simple, therefore should have IO Link, or this sensor is complex, therefore should have its own industrial Ethernet interface. There's almost a little bit of a gray area, but you're right. We kind of leave it up to the vendors to decide, hey, my thing needs the horsepower and it's so complex that I need something like an industrial Ethernet protocol. But you know what? This other sensor line is tailored for low cost, and so therefore I'm going to put IO Link on it. But that's up to them to decide. So when we talk about IO Link in terms of benefits, we kind of like to make the analogy with USB, because everybody knows USB. You got your USB cable, you plug it into your computer on one end, on the other end you plug it into you plug your mouse in, or you plug your keyboard in, you plug your printer in. Automatically it uses the same cable. It's always the same. Everybody's using that interface, and we kind of see the same thing with IO Link, where it's just a unified, unshielded 3-wire sensor cable, and it can be used with all IO Link devices. Up until now, if you had smart devices, right, memory and computing power is smaller and cheaper. Up until now, to get that extra information out, you would need multiple cables. The wiring is time consuming, it's expensive, they're large, costly to install and maintain. But with IO Link, you just plug it in. It's a simple M12 plug, and then you don't have all these spare parts of different cable types. It's just one cable, and easy to maintain, thin, flexible. I've got an example here I'd like to highlight, and I'll try and talk through it for those that are listening instead of viewing. This is an example of 256 IOs via 16 field bus modules, so like like remote IOs, or whatever the case may be. So we're connecting them to a PLC out in the field, and to do that, we would need 16 field bus modules in order to do that. These are just let's call them simple DI, digital input proximity sensors. With IO Link, we can do that via just one field bus module. So that's just one IP address or one IO Link master. So already you're cutting out 15 of those more expensive devices. And then we use what are called so-called IO Link hubs, which bring those DI signals, put it all on one IO link connection, put it into IO link master, and send it out the other side. And with that, we can connect, if you imagine these 272 IOs, as shown here, via just one field bus module. So it's just huge, huge, huge savings simply on cost alone due to the wiring. And that one cable, it fits all sensor types. So simple sensors, like a proximity sensor, all the way up to complex devices like pressure, temperature, signal lamps, and even simple actuators all use the same IO link cable.
So where an IO Link device would be giving you not just on or off, but a lot of other information and some of that analog information. If all you had was a dumb device, well, now I can put 16 of them or so, some number of them together, bring them into a hub, and since each device only has an on or off, where a regular IO Link device would have lots of other information, you can now just join them all together and say, okay, here we go. Here's inputs 1 through X.
It's almost like multiplexing, put it all together on one and then pump it out the other side. Yeah.
Perfect.
The other way we relate IO Link to USB is kind of in the identification and parameterization. So if we look at how you plug your printer into your computer, you plug it in and automatically your computer says, oh, okay, I know that that's a HP something something desk check printer, and okay, how do you want to do you want to do color or black and white? Do you want to do full duplex? Do you want to do back and white, back and front on the printing? And the same is true for IO Link. So you plug in that IO Link sensor into your IO Link master, it reads it, says, hey, the IO Link says, hey, this is who I am, this is my type, this is my serial number. Every device has a vendor ID and a device ID. And then the IO Link master goes up and gets the IODD file, and I'll show that here in a little bit. And then you can start that parameterization. And it's just like a USB. It's no special knowledge is required. You can format changes very, very easily. You can even do them on the fly, for example, with an HMI on the machine. And the identification methods make sure that you don't plug in a wrong device into an IO Link port, which could stop the machine. It'll recognize that and prevent incorrect connections. It allows you to exchange devices very easily of the same type or the same manufacturer, same device. So just like USB, it kind of works in that way. And the other way, it's kind of like USB is in the diagnostics. And this is a really, really powerful part of IO Link. So when your printer says, I'm out of paper or I'm out of toner or there's a paper jam, it sends that signal, standardized signal to the computer, to your computer, your PC, and you know exactly what to do, how to fix your printer, why your printer isn't working. The same is true for IO Link. We've standardized these diagnostics. So this is a photo eye saying, hey, under voltage or over temperature, or the window on the photo eye has gotten dirty, so signal quality is deteriorating. So we've standardized all this so that these diagnostics all come in the same way, and you can, fix any problem as fast as possible to minimize downtime. And in the case of things like signal quality, hey, the window's getting dirty. This enables things like preventative maintenance. Oh, I know I'm going into a planned shutdown next week. Now's the time to go out and clean those sensors, kind of thing, because I know that the signal is deteriorating. So some cool things like that that wouldn't be possible with a traditional analog signal, which we're showing here. And it also makes really no sense. I mean, in this example, what we're showing here is a generic. This is a pressure sensor. It does its measurement. It then does some amplification, and then to stabilize the signal, it does an A to D, puts it into a micro, which does some temperature compensation, linearization. But then traditionally, prior to IO Link, what you do is then do another D to A to send it out via 0 to 10 volts or 4 to 20 milliamps, whatever, into an A to D card on the back plane of the PLC. I mean, this is just crazy. It's time consuming. It's the signal is still susceptible to interference. The analog inputs on the cards on the PLC are expensive. There's manual calibration of the signal. But with IO Link, it just makes sense. You take that signal right from the micro, pump it out digitally via an IO Link inexpensive interface to your IO, and we use that unshielded 3-wire inexpensive cable, and then you get all those parameters and diagnostics. And really, that's the point. of using IO-Link is all that extra data, all that extra information that comes along with the process data.
Yeah, and so those of you who are listening, I mean, what we saw there was to shoot out a 4 to 20 milliamp signal or 0 to 10 volt signal, it had to convert it from the digital value that was inside the device to analog. Then I have to pump it out. And, we always have to worry about noise and, shielding and all that, depending on the length of the run. And then in the PLC analog card, it's converting it from analog back to digital. So you have that 0 to 32,000 value or 0 to 64,000, whatever your PLC does. And so IO-Link does eliminate that. It eliminates the noise of your traditional analog. And I know I've met so many customers say we have no noise issues on our analog, and that's great. But not everybody's in that same boat. So you're eliminating that D to A and then A to D. And that's you're keeping everything digital. So you're not only getting a cleaner, more accurate value from your device, you're also getting all those additional pieces of information and the ability to maybe configure the product. Some of these products need to be changed based on the type of product they're sensing, the type of fluid going through, the recipe that's being run, the lighting, the colors. So all those different things, you can't, with a typical analog signal, you're not going to be able to send back and do a configuration to it. So go ahead, back to you, Michael.
No, you're right. Exactly. We have. I took the slide out of this deck for brevity, but we show examples of particularly food and bev, right? Where you have batches. I'm running a different batch. I'm running a different product. I need a different label on the bottle or whatever I'm running through the machine. You reconfigure that via the HMI. It sends all that stuff down to the sensors. Okay, now I know I should be sensing this instead of this.
Yeah, it could be a clear bottle sensor, the clear bottle detector, that the bottles change colors. So it has a different setting, or it could be background suppression, depending on the color of the product. You need a different setting or a color sensor. Maybe you're making different products and the different colors. And so, all this is now configurable through your PLC, through your control system, through your HMI, which I just think is so cool.
Yeah, it's super cool. All right, let's get a little bit technical here. I think for some of the engineers, that might be nice. The IO-Link signal and 24-volt power supply, like we talked about before, it's an M12 connector. So you've got 5 pins. Your pin 1 is your high, pin 3 is your low, and then pin 4 is your CQ line. That's where the IO-Link digital signal lives. It's serial, it's bidirectional, it's point to point. And then we also have on that same pin 4, if you so desired, you could also parameterize your device via IO-Link, set it all up, and then put it in what's known as a CO mode or simple IO mode. And I'll show that on the next slide too. If maybe you've just got a digital IO that you want a fast switching interface. So pins 1 and 3 are power. Pins 2 and 5 are freely assignable. So for example, if you wanted to use that pin 4 for your IO-Link signal and then separately have your own DI or DQ line, you could do that using a 3-wire, 4-wire, 5-wire cable. And then what's cool also in IO-Link, and we're starting to see this more and more, is we call this port class B, same M12 connector, same 5 pins, but pins 2 and 5 provide a separate power supply for additional power because, and this is cool, we're starting to see more and more IO-Link, just like simple actuators on the market. And that's really neat. So let's say you've got some simple linear actuator, not a complex, driver, or motor or something like that, but a simple linear actuator. You can drive that via IO-Link if you just got to move something really, maybe even connected to the same ports on the master as some other sensors. And so you can do that logic in the master itself, simple stuff like that. But that's also possible with IO-Link where you can drive it, not just sense it, but also actuate it with IO-Link. So that's some cool stuff that's coming down the line.
And I found that all the IO-Link devices I had here, they came with the SIO mode already set up. So I was able to use the photo eyes and the proxies and all the other devices just as simple IO devices and without even touching the IO-Link side of it, which I think is cool because, in many cases, you just need a photo eye to get up and running, right?
Yeah, and that's how they come out of the box. So out of the box, it's in that CO mode. And I think you kind of touched on this before. Maybe many customers have IO-Link devices on their machine. They don't even know it because they took it out of the box. They needed that photo eye. They plugged it in and away they went. But there's also all that extra stuff. If they wanted to, they could get down into the IO-Link part of it. Maybe to reparameterize it. Or what if you got to change a you still want to use the CO mode. You just want that digital input. What if you want to change the switching distance, for example, something like that? I don't want it to switch at 1 meter. I want it to switch at 2 meters or whatever. So all that can be configured via IO link. So if we talk about the IO link communication itself, there are 3 transmission speeds: comms 1, 2, and 3. COM 1 is 4.8 kilobits per second. COM 2 is 38.4 kilobits per second, and COM 3 is 230.4 kilobits per second. IO-Link masters support all 3 COM modes, but devices are free to choose based on what they're sending. If it's temperature, maybe you don't need COM 3 because that's changing more slowly than something like if we're talking about a proximity sensor, which may want to send that a little bit more quickly and uses that COM 3 mode. Many devices use COM 3 mode because still 230 kilobits per second, that's not going to kill you. And then a typical cycle time, because this is the question we get all the time, is what kind of cycle time can be achieved? It's about a millisecond at COM 3. So if you're trying to go sub millisecond, maybe IO-Link is not the solution at that point. But for many applications, that 1 millisecond cycle time can accomplish whatever they need to. And then what's cool is that from the IO-Link master's perspective, it'll have 8 or 16 sensors connected to it. Each device can be set independently. So on this port, this device, I'm talking at this COM rate and this cycle time. This other port number 2, I'm speaking at a different transmission speed and a different cycle time, and so on and so forth. So that you're not sending data unnecessarily that is simply just being sent for the purposes of being sent. And that's pretty cool.
And a lot of times you don't, because you're not reading a digital on off, the speed, you're actually getting a value, and that value, a lot of times your PLC is not going to be running faster than a millisecond scan time. So if you're getting your value updated, faster than the PLC, then that's really what you need. How fast is your PLC running? How fast can your program controller use that value? And, I'd be hard pressed to see a lot of applications where they're breaking that 1 millisecond update rate. The other thing, too, is just because we're talking at this speed doesn't mean the actual calculation is even possible in a millisecond. So, temperature change, there's things that
Yeah.
sensors, there's limitations to the physical world. I don't know if anybody's ever said this to you before, Michael, but when I first saw the whole COM thing, I thought that was confusing because having grown up with PCs, I always thought of COM port 1, COM port 2, COM port 3, right? And these are really just what I would call from the old days, sword rates, right?
Yeah, exactly.
Any insight why is it just maybe because it was the standard started overseas, or any idea why they went with COM?
I'm not gonna lie to you. That's the first time I've gotten that question.
Really? Okay.
Why they're called that? Yeah. Let's just rewrite this and call it BOD 1, BOD 2, BOD 3.
I know it's just so weird, but anyways, sorry, audience. I just have.
That's a good one. That's a good one.
Uh,
I'll take that one back. All right. So IO-Link data comes in a couple different flavors. You have your process data. That's your bread and butter, what you're using to run the factory. Transmitted cyclically in a telegram. The data size is defined by the device, and it can be up to 32 bytes for each device, both input and output. Along with that comes a value bit indicating whether the process data is valid or invalid, and this can be transmitted cyclically with the process data. And then you have things that happen acyclically. These would be device data like parameters, identification data, diagnostic information, and these happen on request of the IO-Link master. Obviously, a lot of that happens during startup, but also can happen during runtime if, as shown here on the slide with the last case, events can be error messages. So the device will set a flag, hey, there's a short circuit or something, and then the master can poll that device for more information, more diagnostic information, based on that event flag that's set by the device. And so the question we always get at this point is, how do I make this all work? How do I integrate this stuff into my plant?
Before we go any further, I did want to jump back and tell you about a service I'm doing that I don't think I've talked about very much. And it comes in two different flavors. First of all, I've actually had some vendors and companies reach out to me and say, Sean, I know you don't want to travel all around the country with all your equipment, right? That's not what you do. But we want you to come out and teach us something. Would you come out and do a lecture? We'll set up our own equipment. And can you come out and just run us through some of the products and teach us some of your knowledge? And you don't have to worry about bringing all the equipment with you. And so that's something I really don't talk about much, but I did want to tell you that if you're looking for training and you need it on site, of course, you do have to pay for my travel time. But if you do want me to come out for a day or 2 days or for a week and do training on any of the products I train online now, if you want me to come out and do training on a product I don't already have a curriculum on, I can't do it. Building the curriculum is where all of my cost is on the training, right? I shouldn't say that. The web service in the back end does cost something every month as well, but most of the time goes into, and that's really what being self-employed is, it's time, right? Most of the time goes into building the curriculum. So if you have a need for somebody like Sean, we can't do a webinar, we can't do a Teams meeting, we can't do online training. We want you to come out. And again, I just got a call on this yesterday. Yes, I can do that as long as the curriculum I'm going to teach you is something I already have existing. And I'm not going to hand out lab books. We can buy you lab books if you want. People sell great lab books for $80, $90 a pop. If you want lab books, I'd be more than happy to include that in the quote. But in any case, that's one thing I do. The other thing I've been doing with vendors is they've hired me to come out and interview them at their trade show. So usually what happens is somebody will sponsor a podcast for $5.99. They'll come on, we'll do the interview. I'll edit it all up. I'll put their links in. We'll talk about the thumbnail, and then we'll release it ad free, right? And so that covers my costs of producing that episode roughly, right? We just raised it from $4.99 to $5.99 because most of the shows were actually upside down on. So we needed to raise it a little bit to make sure we're covering our costs. But in any case, sometimes vendors have, they have their own trade show and they may have all of their product specialists there. And they're like, hey, Sean, we would like to do 6 or 7 interviews at the trade show. Would you come out and actually record them there? We'll pay your flight, we'll pay your hotel and your expenses to get there and back. And so that's another thing I haven't talked about much that I'm doing. I'm working with some, top 5 vendors to do that. And I've done it in the past. And so I did want to explain it to you if you're a vendor listening, or if you are talking to your vendor, you're like, you should have Sean come out and interview all your people. You have them all in one place. Let them know that they can contact me about doing that. Again, you can contact me at theautomationblog.com, LinkedIn, YouTube, theautomationschool.com, pretty much any way you want. You can write me snail mail if you want. But in any case, I did want to share that. And we also have in-person training. I think I've talked to you guys about this quite a bit. We do custom in-person training for as little as 2 people, $900 a day, up to 4 people. And so if you want to get some people in here, we can actually do Allen Bradley and Siemens in 2 days, back to back, 1 day Allen Bradley, 1 day Siemens. So if you want to learn 2 PLCs and 2 days back to back. Now I did have somebody ask me, hey, Sean, where's your schedule of upcoming courses? And back in my previous life for 25 years, we were always trying to sign people up and then canceling, events and classes because we wouldn't get enough people to meet the vendor's minimum. So I don't want to do that. So I don't have actually any dates now. I have been toying with doing a intensive PLC boot camp, but I just got so much things going on in my life right now that I don't think I can pull that together this fall. But in any case, if you need some training, you want to send your people here, we can even start at like noontime and then end the final day at noontime so you can get your flights and travel and all that. We're 1 hour away from Albany, New York. And that's a great little airport to fly in and out of. Actually, I'm flying out of it in November to go to a trade show to interview with vendors product people. But in any case, I just wanted to break in. There's something about my company I don't think I ever talked to you guys about much. And so I just wanted to insert it here since I'm sponsoring this episode and eating the cost to produce it. I wanted to share that with you. And now I won't be back until the end of the show. So please enjoy the rest of this episode. Send any feedback you have to me. And we'll talk to you at the end of the show.
And it kind of works like this. So you have your IO-Link device, which has an IODD file, which we mentioned earlier. That gets ingested by a parameterization tool. The parameterization tool comes with the IO-Link master. It could be a separate piece of software. In some cases, could be a web page built into the IO-Link master itself. Depends on the vendor. But then what happens after that, how that data goes from the IO-Link master to the controller, the PLC, is field bus specific. So you have your own field bus file, GSD or EDS or ESI, whatever the case may be, which is ingested by the engineering tool of the PLC and kind of way outside the scope of IO Link. And so the EDS file, the GSD file, and that data then gets sent via field bus, and that's the sum of all the IO Link device data from all the ports on the IO Link master, where that IO Link communication, as defined by the IODD file, configures the port for the master and for the devices. And so an IODD file is provided by the devices, and every device manufacturer must provide an IODD for their device. It can be downloaded from the IODD Finder, which is a website, and it describes what the entire device does. It describes the process data length, the process data structure, the parameter, the name of the parameters, what range to expect, the data types, the addresses of the parameters in the indexes and subindexes. It can talk about GUI information, pages on which a parameter shall be displayed, names of parameter pages. All this kind of stuff is in an IODD file. It's a zip file where you have that IODD as an XML. So that's how we format the file. So it's both, and this is the key part, both machine readable and human readable. It's got a little picture of the device, picture of the manufacturer logo. And with your permission, maybe I can show the IODD Finder. Let's ioddfinder.io-link.com. Looks simple enough. Let's say we want to look at I'm going to type in something here. Max ref let's pick this. So this is a reference design, not an actual product that an end user would employ in their factory, but a reference design of something that maybe a device manufacturer would use. And it shows the manufacturer name, the article name, number, the product name, the device ID. All that stuff is ingested by the parameterization tool, which then uses that information to go up to this IODD Finder and grab the IODD file shown here, which can be downloaded if you wanted to look at it yourself. But in the past few years, we implemented what's called an IODD viewer, which is pretty cool, which takes that nice XML file and parses it. So in human readable form, if you wanted to compare quickly, hey, I'm an end user, I want to compare the IODD file from device vendor A to device vendor B to kind of see what kind of features they have, you could do that all very easily. And that's shown here in the IODD viewer. What's really neat about this IODD Finder is that it has two ways it gets accessed. That's this website that I just showed here. So as in humans are accessing it, but it's also accessible via API. And we track the traffic to the IODD Finder, and the vast majority of the traffic comes via API. So these are IO-Link masters that just had a device connected to them. Parameterization tool that has or connected to the IO-Link master that had a device connected to them. They go up to the IODD Finder and they pull down that IODD file for the device that was just connected, so that now they can be configured. And that's really, really cool stuff. So all these IODD files are in one spot, in one database up there for viewing, or via the IODD viewer, or for access from any number of IO-Link tools out there.
So when we're talking about API access, we're talking about the tool we're using to configure the master. So it could be a web page built into the master, or it could be a separate software program. Do I have that correct?
Yeah, right. So the parameterization tool, is usually a software package that'll run on your computer, connecting to your IO-Link master that parameterizes the IO-Link master. Yeah.
Excellent.
Or through the network somehow, maybe through the network. Yeah. Goes out and grabs that IODD file from the IODD Finder to parameterize that port and that device.
Which is excellent, because in previous iterations of smart networks and smart devices, you always had to go searching a vendor's website, and then people would get the wrong file, and then I would be in the field saying this is never going to work because you get the wrong device file. If they can't give you the right device file, you'll never get it to work, And so this is much better, having the organization have everybody who has IO-Link to put their IODD files in the one place so everybody can always find it. And so the software tools can find it automatically for you, which is, I just
Exactly.
think, a huge change versus what we went through in the 90s.
Exactly. It came on a CD or something, or what. I mean, God only knows. I'm going to switch gears a little bit here. Talk about two subtopics within the IO-Link domain, and one of them is IO-Link wireless. This is what we call is bridging the gap. So it's an IEC standard, 61139, as of November 2023, and it's enabling connections that simply weren't possible before for IO-Link. And in an example here, we're showing a smart machine tool where the IO-Link sensor is integrated into the chuck of the lathe. Now that guy is spinning at 6,000 RPMs. That connection simply couldn't be done any other way than with IO-Link wireless, or let's say independent movers. So you've seen these moving systems where you've got the either floating or on a rail. Yeah, the track systems, exactly. If you integrate the smarts of IO-Link onto the movers themselves instead of using SCARA or Delta robots to do I mean, you're saving huge amounts of costs that way if those guys can move on their own. And they use IO-Link wireless to do that. Slip rings, where certainly sending power is well known, but sometimes communication can be tricky via slip ring. End of arm tooling, like robot end of arms, where you're going to change the tool at the end of the arm. It's more lightweight, saving on robot costs that way. Lighter robots can be used. But it's cool. The architecture looks pretty much the same. Where you have your field level, your IO, and instead of wired connections, it's simply a wireless connection. Instead of wired, it's wireless. And what's different about IO-Link wireless is that it was built for industry. So I think in the past, people have been burned by wireless technologies that made some promises that didn't maybe, they couldn't meet the rigorous environment and requirements of industry, but that was different. It was built for industry from the start. So it uses the 2.4 gig license-free ISM band, and what we do is this frequency hopping, so that we use the same IO-Link, data structure. We do this frequency hopping, and it's a cycle of 5 milliseconds. So you're not going to get that 1 millisecond time that you get via wired IO-Link. We do a 5 millisecond cycle time, and then it's using this frequency hopping method. It's basically cable grade connection, 10 to the minus 9 error probability. You can have hundreds of wireless devices in a machine, and it's deterministic. It is designed from the outset for control, of course, but of course also for monitoring. And maybe like a brownfield, you can't get IO-Link to a sensor or something, that you can maybe use IO-Link wireless to get access to some hard to reach sensor. But,
well, I think this is so interesting. We actually had a company on, I think a year or two ago, who does IO-Link wireless, and that was the first time I had heard of it. And he said, yeah, hundreds of devices, right? It's pretty amazing. Especially if you have a lot of things, the smart devices that need to be, free from the network, need to be wireless. Maybe, the slip ring communications has been a problem for years and years. Because this is frequency hopping, it eliminates a lot of the problems with interference, right?
yeah, right, exactly.
And it's just, and I highly recommend people look into this. If you're challenged, you can't run a wire to every sensor or every device. This is definitely some very interesting technology.
And just like with, so I didn't mention it explicitly, but when we're talking about IO-Link wiring, there's a 20-meter limit for wired IO-Link. And we talk about the same thing for IO-Link wireless, that you're not going to be going hundreds of meters wireless via IO-Link wireless. So we stick to that 20-meter limit for IO-Link wireless as well.
Great for a cell, great for a robot, great for robot tools, right? But yeah, this is not going to replace your Wi-Fi or your LTE or anything like that.
Yeah, if you're in a a tank farm or something. You're not going long distances
Hmm. Hmm.
across a plant like that. All right, in the last couple minutes, one more thing I want to talk about. This is pretty new. You're not going to find devices out, or at least many devices out on the network like this. But this is functional safety for IO-Link. So IO-Link safety is a really clever name, but IO-Link safety, because today you've got, if you want to do functional safety, you've got your FSCPs, or your functional safety communication protocols like FSOE or SIP safety or ProfiSafe, or whatever the case may be.
Hmm.
You connect it out to your remote IO, but every single device needs a different interface. If it's a relay, it needs maybe a DO. If it's a e-stop, it needs a DI. If it's a analog signal, it needs its own functional safe analog input. With IO-Link safety, we can get rid of all those separate interfaces. Just use IO-Link for that. For any kind of safety measure, functional safety measuring sensor, functional safety switching device. Maybe if the drive has a safe input on it that it could use, all of that can be done with a functionally safe IO-Link master and IO-Link safety. And it's the same concept as IO-Link, where we're transmitting this data via IO-Link, but we transmit both safety and standard data from a device. You can migrate IO-Link safety and OSSD, so output switching signal devices, can be done in the same product. The masters also offer generic IO-Link standard operation. They offer the OSSD mode, and it's cool because you don't need any switches for safety addressing. The watchdog time is set automatically. You can exchange devices without a specific tool, just like with regular IO-Link. And then it's just that regular IO-Link connection of 20 meters, flexible, no shielding, inexpensive. And this is pretty new stuff. We just, and I'm talking like this month, got the TUV, the TÜV certification for IO-Link safety. So we're expecting this to ramp up quickly over the next couple of years. Again, for the same reason that IO-Link grew so fast, and that's the no competitor, and you're saving on a lot of costs by using it.
Does it simplify the wiring? Because in your photo on the screen, you show the safety sensor with the two, let's say two relays, right?
Mm.
Uh, and you have to wire both of those up to the input, the safety input, right? Functional safety digital in. With IO-Link safety, are we running just one cable?
Just one cable, yeah. It's the same IO-Link cable, exactly. Yeah.
So just like with let's say SIP safety or ProfiSafe, where you're still just running one Ethernet cable.
Mhm.
Here we're just running one IO-Link cable. So you are simplifying installation, I think.
Yeah, and it uses some of the similar concepts, mainly that whole black channel principle
Okay.
that we know from all the functionally safe protocols use. That what you care about is making sure that signal gets from one end to the other. Now, it's a whole heck of a lot easier with IO-Link, because IO-Link is point to point, not going over a network. So that becomes a whole heck of a lot easier. But that's great. I mean, it's just one wire. You don't have to. Okay, did I plug it in? And, is it normally open, normally closed? Do you have both? Do you have three of them? It's just that one IO-Link connection. All right, I think I'll wrap it up quickly here. So a lot of this focused on end users, people installing IO-Link in their machines or in their factories. But if any listeners are sensor manufacturers, device manufacturers, there are really two main ways to get an IO-Link device certificate. There's the membership route, and then there's a license model for those that may, for whatever reason, choose not to become a member. And with the license model, I'll start on the right-hand side and work backwards. You implement IO-Link, request the test at an IO-Link test center, and then you get your IO-Link vendor ID from PI, and then you get your product tested at the test center. And then every device has a manufacturer declaration. And when I mentioned the IODD finder before, when a device manufacturer uploads that IODD file to the IODD finder, they also, at least in the last couple of years, we've asked and required them to do that. They also upload the manufacturer declaration. So end users can see, hey, the manufacturer has tested this device, certified, and they can rest assured that it's going to work as specified per the IO-Link specs and standards. And then in the license model, you got to purchase a license per device and acquire patent rights Just about nobody goes this route, but it was initiated for political reasons. Some companies or company didn't want to join PI, but just about nobody does that. And most go the membership model route where you join, get your IO-Link vendor ID, implement IO-Link, and then we allow members to self-test using any number of testers that are out on the market. And then you can sign the manufacturer declaration yourself, which is basically self-certification. If you want to learn more, these slides were taken from a slide deck that's presented a couple times throughout the year at an IO-Link one-day workshop. And this is a very special Sean Tierney resource. We don't, display this everywhere. But if anybody wants to get access to this stuff, they can go to io-link.us/2025. It'll ask for a little password. The password is 2025. And you can download the training class manual. The full slide deck that is performed and really demonstrated at these IO-Link workshops. So like I said, we do 4 of these throughout the year. We did 2 already, one in Seattle, one in Philadelphia. And then we've got 2 coming up in October, one in Vancouver, British Columbia, and one in Richmond, Virginia. So if anybody's listening and in those areas, it's a free class. You get lunch, you get a day of learning all about IO-Link. We do a lot of demonstrations. We get down into the bits and bytes a little bit. And then what's cool is at these events, a bunch of vendors, maybe a dozen or so, show up with products. So if you want to walk the room, it's kind of like a little bit of a micro fair. And they support the event, which is how end users are able to come and get a free class and get a free lunch. So go to iolink.us/events. And if you're in those areas, we welcome you to join us at one of these classes. And that's my plug. Yeah.
Yeah, and I just want to focus in on this for those who are driving. So Vancouver, British Columbia, October 1st.
Oh, yeah.
Richmond, Virginia, right? East Coast people, October 28th. And io-link.us/events. So just wanted to say that again, because sometimes they're driving, they're like, well, I didn't hear it, or, so, hey, look, if you're on the East Coast with me and you're near Richmond, October 28th, sign up early. Don't sign up often. Just sign up once. But if you have friends you want to meet there, have them do that. And it's great that the vendors come and make the events possible. Yeah. And it's nice just to get that one-on-one. So many of us are so busy. It's nice to get that one-on-one with the vendors. I've actually been with the vendors at these shows, and it's the audience, the attendees usually have some awesome questions. And a lot of times they ask you about things not even related to it, but they just see you, so they want to talk to you. So definitely want to shout out to all the vendors who are going to be there as well.
Yeah, it's a great, it's learning, it's product if you want it to be, but the content like this it's not salesy at all. It is an educational event, but if you do want to talk to the vendors, then that's great. They're there to help you out, because at the end of the day, you can't buy an IO-Link, right? It's just a standard. What you can buy are the products that use it. And so that's why we work together with the vendors to put these events on.
Yeah, it's awesome.
Yeah, and they're it's really impressive that they're willing to get in a room with really their competitors and do this and put this together. The last one I want to mention is Profi News, but we talked about that at the beginning. This is that monthly newsletter that we send out to 130,000 of our closest friends. And maybe you're receiving Profi News. If not, you can go to the website. It's simply profinews.com and subscribe to Profi News, where those new products, particularly IO-Link products, are mentioned and highlighted.
Yeah, one thing I like about this is, if you get too much email like me from sources you don't want it from, it's nice that you can go to the website and pull it down when you want to see it, right? So maybe you've been a couple of months and you want to see what's new on IO-Link. You can go up there. Their website is excellent. You can go and look at all the articles, all the different new products that have come out. And you don't have to, if I know a lot of people like the newsletter subscriptions. I'm one of those Gen Xers who don't. And least, I want like like I want to hear from Michael. I want to hear from Tom. I want to hear from students like Daniel. I was emailing yesterday. I'd every vendor. There's hundreds we follow. If I had a newsletter from each of those, it would my inbox would be full. So, but in any case, it's excellent, guys. It's no fluff. It's really and I've discovered new vendors from just following that list. These people I didn't know from my past. And in any case, highly recommend you guys all check it out at least once or twice a year if you don't want the email.
I appreciate that. Yeah, and like I said, and right there at the top there's a button that says product news. Click that, and then it'll be every month's worth of new products section article that we published
Yeah,
forever, ever, ever.
there's some great articles up there too. So thank you very much for publishing them and keep up the great work on those. I know we enjoyed them during the couple of years I was doing the news. We would go up there on a regular basis.
We're gonna send out issue number 251 next week.
Oh, wow.
So every month, that's, do the math, 20 years worth of crazy.
Good job. Good job. Keep it up.
That's all I got. Once again, thanks for having me, Sean.
Michael, I really appreciate you coming on, and that was a great update. And thank you for including some real technical details in there. We will be using the opportunity of having this episode to go ahead and cover more IO-Link products. So we have had a number of vendors send us products, but with non-sponsored products. So it's hard to find time to use things when everybody says, "Well, play with it in your free time." I think we've all heard that. And but in any case, so we have new lessons coming, we have new videos coming, we have new demos coming. So stay tuned, folks. But again, Michael, thank you so much for coming back on the Automation Podcast. Let's not wait 4 years. Let's get back on in a few months to talk about MTP, and because I think that'd be cool, and then maybe Noah later on.
Yeah.
But thanks again for coming on the show. Really appreciate it.
Oh, my pleasure. My pleasure.
Well, I hope you enjoyed this episode. And I want to thank Michael for coming on the show and bringing us up to speed on IO-Link. We hope to get Michael back on in the coming months to talk about MTP and Noah and some of the other things that they've added to their portfolio since we had them on 4 years ago. But with that said, I also want to thank all the members out there who've joined my membership program. I look forward to the day when we can grow that above the 2 to 3% mark and actually start doing content dedicated for what the members are asking for, right? So you guys can ask, hey, cover this, cover that, and we can actually afford to do that. So thank you, all the members out there. I know you just love to support the channel, and you really are very busy, like most of us are. So in any case, I just wanted to take a minute to thank you. And I also want to thank all my students over at the Automation School. Did you know I've added a bunch of new lessons lately? So especially to the PLC classes. So in any case, and I got a bunch more planned this fall and a lot planned on IO-Link. So you're going to see a lot of content from me on IO-Link, both on the lunchtime show that I've been doing, as well as in some upcoming episodes of the Automation Show and the Automation Minute. So it's something I've wanted to do for a long time, and the stars have just aligned. So we'll be covering IO-Link a lot, both on the blog, on the channel, and over at the Automation School as well. And with that, that's all I got to say. Thank you very much for making it to the end of the show. I want to wish you all good health and happiness. And until next time, my friends, peace.